All right, can you see my screen?
Yes, sir.
Yes, sir.
That's the thing we talked about in the previous class, right? We introduced some different type of vector, and we talk about basically the vector triangle law, the only law I introduced over here, which is a very important law. All right, then we also talk about how to add, and basically the vector triangle law actually the basis to add or the subtraction of the two vector. We can use that vector triangle law to add and the subtract of two or more than two vector actually. So fine, we say that, say if you have a vector, say I have a vector over here, then this is I expressed by a letter A. Another vector is over here is head to tail connection. Then we say that the resultant vector would be that way, right? Which is actually the C, and we can write this C or the resultant vector would be basically sum of these two vector. But there is some condition. I say the condition is the vector must be oriented in such a way that head of the first vector is connected to the tail of the second vector, which is I said that head to tail connection. It has to be, otherwise we cannot use this vector triangle law. All right. Now, say I have a situation like that, a vector in that way, and another vector in B, which is basically tail to tail connection. I want to find out what would be the resultant vector. Remember, probably you know that if you have a two vector, then if they have a equal magnitude, the resultant must be goes in between of these two vectors, right? You know this thing? Probably you know this one actually. If you have a two equal vector, they are in such a way, then if the angle in that way actually, so you can say that if the magnitude of these two vectors are equal, then the resultant vector must be goes in between them. It is actually that we can find out actually the two way. One I can do, I said you, I can basically the replace the B, or I can relocate that B actually. If I draw, say I'm going to shift that origin of the B, this is would be the new position of that B. Then I can write, so this is would be my resultant vector, which would be A plus B, right? Which is actually I'm using the vector triangle law because head of the first vector A, which is connected to the tail of the second vector B, which I actually the relocate that vector, or I just shifted the origin of vector B. Fine. What about say someone say that no, I'm not going to shift it the B, I will keep the B fixed, I will shift the vector A. In that case, what would we say if I shift the origin of that vector A over here? So this is would be actually that new location of the A. I can do that, right? Without changing the direction and the magnitude. I can shift the vector anywhere I want in the space. I have that opportunity, or I have that power actually. You have also, you can do that. But condition is you cannot change the direction and you cannot change the orientation or the magnitude. It means that the vector will be remain same. It's not going to be the change. Fine. If we do that, then for the second case, now look at this. B is my first vector, A is the second vector. They are again head to tail connection. Then definitely the resultant vector would be also in the same direction of the previous one. Then I can say this one would be basically that B plus A, right? Which is exactly the same vector of A plus B. Then I can write B plus A must be equal to A plus B, which is another law we define in that. This called actually that commutative law. If A plus B equal B plus A, then this is known as actually that commutative law, which is the extension version of that vector triangle law. I'm using the vector triangle law again over here. This is known actually that commutative law. Fine. What if, say, I have more than three vectors? They are in different location. I rearrange them for my convenience. Say this is that vector A, this is that another vector B, they are head to tail connection, and the vector C is that way. So this is the vector C. I rearrange them in that way so that I can use the vector triangle law. Over here, I have three vector, right? So we know that for the vector triangle law, we require the two vector. But over here, we have the three vector. I can use that one step by step. Initially, I will use for A plus B. Say they are a head to tail connection. I will find out this is would be A plus B vector, right? I can write this will be the A plus B. In that case, I can neglect this AB because that will give you the new vector which is A plus B. Now this A plus B is again head to tail connection with the vector C. Then I will say the resultant vector would be this one. Sorry, resultant vector would be this one, which is actually the tail of the first vector towards the head of the second vector, right? So that's why I can say this one would be A plus B plus C, right? This is actually the vector. What if, say, instead of adding A and B, you are going to add B plus C first? You can do that also. So if I add, say, B and C first, I will find out this one, right? This is would be actually B plus C vector because they are again head to tail connection. And with respect to that vector, A is again head to tail connection over here. Then I can write this vector would be again because the resultant direction will be the same because I'm not changing any vector over here. The resultant would be the remain same. But I'll find out in that case it would be A plus B plus C. So that means these two vectors are again same. So we can write this is A plus B plus C must be equal to A plus B plus C. This is another law we say. This is actually that we call our associative law. Associative law, which is also the extension version of the vector triangle law. Using that vector triangle law, basically we can find out, or graphically we can find out, or we can predict actually what would be that resultant direction. And this method actually they're very helpful for predict that trajectory of that particle. All right.
Sir, what was the name of the first law?
Vector triangle law.
So no, the one before this one, this
It's
one.
called the commutative law.
Okay, sir, thank you.
All right, let's define If you want to express the vector mathematically, how we are going to define? Say, if you say a vector A is 5i, right? For say one-dimensional case, actually, if we define in that way. Now I know 5 is a scalar number over here. Now I hat is unit vector, right? Do you know this one? I hat is a unit vector. Do you know what is I hat over here?
Yes, sir.
So I hat is a unit vector, right? We
Yes.
can use any symbol because for the Cartesian coordinate system we use in that way I hat, J hat, and the K hat. You can use any symbol if you want. It's not a big deal. But what is I hat actually? How do you define in that case the unit vector? Do you have any idea? Or what is it actually? Can anyone say me that one? You can say it in your own language. Don't be worried. If you're wrong, I'm not going to scold you. I'm going to make it
So I
correct.
think we can, I mean, to for unit vector, we can just divide the vector with its magnitude and we get this unit vector.
Right. Any other idea? Any other idea?
No, sir.
No, sir.
No, sir. Which is actually if you say that is a vector by vector magnitude, so that's when you were saying the procedure to find out that unit vector. Will it be same for every vector or it will be different?
Probably different.
It will be probably the different. All right. So what is the physical significance of I hat over here? What it actually telling us? If you say A equal to 5i, what comes into your mind? That's very important.
Sir, maybe telling about the x-axis.
Go ahead.
Maybe telling about the x-axis.
Yeah, that direction is x-axis. That's fine. Can you say a little bit more than this? You're on the right track.
Sir, its magnitude is 5 units towards the x-axis.
Magnitude is 5 towards the x-axis. Yeah. So, all right, you're right actually, but it's saying that basically this vector is telling me it is in a Cartesian coordinate system. So this is my positive x-axis and this is my positive y-axis. It's telling me you have to move 5 smallest unit towards the x-axis. If you consider this small box is 1 unit, then I have to move 2, 3, 4, 5. That's vector actually the A. But if you think about this 2 box is 1 unit, then you have to move 10 box over here. Then this is will be the 2, 3, 4, 5, and so on. Right? So that's mean the unit vector basically a basis. You are moving towards some direction, that's fine. How many unit actually you have to move towards that particular unit? Say basically the smallest division in that direction you are considering. The definition basically you guys are known. So if we define a vector, a unit vector, to express the unit vector, basically we use the cap or hat above that letter. That's define the vector by vector magnitude itself. Right? That's fine. Using that one, actually, we can find out that magnitude or the unit vector, but it could be different for the different orientation actually. Right? So basically, this I had actually the smallest division in my axis in Cartesian coordinate system, actually I hat, it would be different for different coordinate systems. Say polar coordinate, it would be r hat, theta hat. Spherical coordinate, it would be r hat, theta hat, and j hat. Different coordinate system has a different unit vector. We'll talk about this thing. But that's actually the procedure you are going to find out that unit vector. But remember, unit vector basically are indicating which direction you are moving and what is the smallest division in that unit. Right, that's fine. And this unit vector basically would be different for different coordinate system. So let's talk about basically for Cartesian coordinate system. So start from the Cartesian coordinate system. So this is my x-axis, this is my y-axis, and this is my z-axis. And this is the origin, right? We choose in that way actually, that orientation. And say I have a point, the P over here. So I'm going to locate that point. So this would be that point, or you can say that OP is a vector, right? Yes, I use that arrow sign over here. And definitely it has some coordinate. That coordinate would be basically X, Y, and Z in the three-dimensional case. Then how I'm going to find out that point or that vector? To find out what I'm going to do actually, I'm going to take the projection of that vector. Do you understand what is
A
projection?
normal drawn on the surface.
Or you can say that shadow, yeah. So suppose if you draw a, or if you put on a light onto that vector over here, over there, if you put on a light, then you will find out the shadow of that one into that XY plane, right? Can you visualize this thing?
Yes.
You can think about it in that way. So if you put on a light over here, you will find out some shadow of that red line into that XY plane. That call actually that projection. So then if you want to find out that OP vector actually, so say I express that OP actually that by vector A. So if you want to reach that point, what you cannot go in there directly, right? What you will do to go first, you will move to the X direction, some length, that is your X coordinate, and the Y direction, some length, and then Z direction, some length, right? That's the idea to find out that location or a coordinate in Cartesian coordinate system. That's fine. Then how I'm going to find out that vector over here? To that one, so say if you say that if your coordinate actually that say that point, I give you some numerical value, say that 3, 5, 7, then you will probably move the 3 unit along to the X direction, 5 unit to the Y direction, and 7 unit to the Z direction or Z direction. Then how you will define that smallest unit? 3 means you have to move the 3 unit, right? 1, 2, 3. So that smallest unit will be that your unit vector over here, the smallest division in your direction. And then we basically generally or conventionally we use that I hat is towards would be the smallest unit in the X direction, which is we define the unit vector, and its magnitude is basically we say that 1, right? We have that idea that the magnitude which is unitary, we say that it's not true that it always will be the 1, right? So you are familiar with that vector I, j, and the k. We say that this is the unit vector is unitary, its magnitude is 1. It's not always true, it could be the different. Like that, if you choose this smallest box is a 1, then it becomes the magnitude with the 1. But if you consider these 2 box, then it's not going to be the 1. For our convenient, actually, we define that the smallest box actually is a 1 unit. So that's why we say that the unitary vector must be the 1. But sometimes it could be the different. That's fine. So that's mean we in that way we have I, j, and that k. These are the basically the unit vector in the x, y, and z axis. Fine. Now I want to basically express that vector A over here. How I'm going to express that one? Say in terms of this case actually x, y, and z, right? Say what could be that vector? Do you have any idea? If I want to express that vector A, what it could be? You know that one. Come on, guys. Probably right now, if you are
So
not.
xi, y, j, and zk.
All right, that's good. Xi, Yj, and Zk, right? Right.
Yes, sir.
This is will be the vector representation of that one. But do you know how it become in that way? Why it is so? Or how we are writing this vector in that form? Any idea? Look at this. This is, say, I know this is actually that I head is a unit vector in the direction of x, right? With
Yes,
respect to that I, x is a scalar over here, right? If I multiply that x with I head, what it will give me? It telling me move towards x direction or that length. This will be the vector x I head.
Yes, sir.
Am I right? That's good. Now this one is basically is same way is a yj head. Now what I can do, I can shift this y high head from here to here. Can I do that?
yes,
This
sir.
will be y j head. Now look at this. This xi head and the yj head is basically head to tail connection. I can use the vector triangle law. Then this is would be my resultant vector, which is would be basically x I head plus y z head,
Yes, sir.
right?
Yes, sir.
I'm using the vector triangle law. Now, this one is z k head, right? I can shift that one from here to here. I can write, I just shift the origin of that vector z k head. When I write this resultant vector xi head and the yj head, I can neglect that part, this one, right? Now my xi head plus yj head vector head is connected to the tail of this zk head vector. They are again over here, head to tail connection. If it is that, then the resultant vector must be going to be that one A, right? Then I can write A would be basically first vector, which is actually x I head plus y z head plus z k hat, which is the resultant vector A. That's how actually we express that vector in three-dimensional case using that unit vector, using that vector triangle law. Simply the vector triangle law. Now, sometime we also represent that vector in another way, actually, that is also familiar to us. I'll come to that point, which is actually a x I hat plus a y z hat and a z k hat, right? Do you see this one? Sometimes they also express in vector in that way.
Yes, sir.
Then what is, yeah, now what is ax, ay, and az? That is actually the component or projection of vector A along to the x direction, y direction, and the z direction. I'll come to that point. Don't worry about that. Before going to that point, we have to understand some properties of the unit vector, which is very important. Properties of unit vectors. So we express this I, J, and the K hat is basically the unit vector in the Cartesian coordinate system. You can use any other notation, it's not a big deal. Sometimes you will find out that they are expressing actually that X hat, Y hat, or Z hat. Sometimes you will find out you're expressing E1, E2, and E3. Any notation they can use actually. It's not a big deal. It's the same thing actually. Basically you say basically a standard reference point you're using some towards some direction actually. But conventionally they use I, J, and the K head. We will follow that one also. But sometimes it could be find out in that way. But don't be worry about that. It is the same. Fine. First, I'm going to say this is basically I'm going to take some properties. Say I have a vector I. If I add I with I, that's going to give me twice I, right? Or you can subtract that one, which is actually addition and the subtraction. You know how to do that one. What about, say, if I multiply I dot I? What would be that? Because we know that in the vector, there are two type of multiplication. One is the dot, we use that symbol, another is the cross, right? These are not the same. This has the two different. One is the scalar quantity and another is the vector. So these are two different things actually. It's not the same thing. There is some difference between them. Now if we take I dot I, what it will give me?
The I square cos theta.
I square cos theta.
Sir, one.
1, yeah. So that's also right. I square cos theta actually. So what is theta in that case? Do you know?
So 0 degree.
Sir, zero.
Exactly. Angle is 0 degree. Why is 0?
So because both are in the same line. I mean,
Both are in the same line. Both vector I and I is basically that parallel vector, right?
Yes, sir.
We talked about this thing in the previous class actually. Then, and remember my strategy in that way. Whatever I'm going to talk about today, on the basis of that, I will talk about in the next class. So that's why it will be helpful if you come to my live session. Before coming to my live session, you should go to the previous lecture. It will be helps a lot. You can understand easily my topics. So it's basically it could be right in another way actually. We write say that I magnitude into I magnitude into cos theta. So I magnitude is basically, since we define the unitary vector 1, so 1 into 1, and cos theta is basically 0 and cos 0 is basically the 1. So that's why it will be 1. So that's mean same way I dot I, you can say that Z dot Z, you can say that K dot K, that's going to be the 1. This is one basic thing. What about I dot J?
K, sir.
I dot J equal to K. Any other answer?
Or maybe it was for the cross product, sir.
You have to know this one. Unless you do not this thing, you cannot.
Isn't it 0?
It will be zero. You have to know this one. That's why I'm taking. That's why I'm telling you. You guys are learning vector from a school life. Then why we are learning this thing in the first day of your university life? Ideally, it should be in the first day of your university life. It should be course for the first semester. But still, we are learning this one. It's very important. Please, guys, this is basically the rudimentary thing of the vector. Do not neglect this one. If you have some lack in that type of thing, then it should be very tough to understand that, or it will be tough for you to handle with the vector. Anyway, I'm talking about from the basic. Don't worry about that. But you should know them because this is actually that ABC of your vector. So I dot I is basically we can use that formula because look at this. I'm using that. You say that's dot product. If you write down the dot product, A B actually that cos theta, right? I'll come to that one where this formula comes and why it is so. Don't worry about that. So using that idea, I'm using over here. Say that I magnitude, J magnitude. I is the first vector, J is the second vector. Now, what is the angle between these two vectors?
90 degree.
90 degree exactly. Cos 90 degrees, and cos 90 is basically the zero. That's why it becomes zero. Right. So that's mean we can write I dot J Z dot K or K dot I. That will be give me that zero. This is two very important properties for this unitary vector. That means the similar identities will be survived. I dot I, Z dot Z, K dot K will give you some value which is 1. But the dissimilar identities I dot J, J dot K or K dot I will be vanished. It will be give you the 0. It's a very important properties. Don't forget about this. I can use the different symbols. Say that X dot X, Y dot Y, Z dot Z. You'll find out something like that in your assignment. So don't memorize this thing, I dot I will be 1. But how it become, you have to know that one. If you do not know, then it will be difficult for you. All right. So now think about, say that I cross I.
Sir, it will be 0.
It will be 0.
Sir,
What is
sine
0?
90 degree is 0.
Sine 0
Huh?
degree.
Sin 90 0.
Sine 0 degree.
Oh, sorry, sir. Sine 0 degree is 0. Sorry,
Exactly. So it would be I magnitude of J, because I'm using for the cross product formula AB, actually that AB sine theta into eta head. This eta head is a very fundamental thing over here. Can anyone say what is eta head over here? Don't worry about that. I'll discuss this thing also when I'm going to talk about the dot product and the cross product. Probably today I'm going to after these topics. But I'm using that one because I know already all of you know these two formula actually. That this is the dot product between the two vector A dot B actually AB cosine theta, and this is the cross product A cross B actually that AB sine theta, and the eta head actually the unit vector, arbitrary unit vector. Look at this. The symbol is different in head. That unit vector must be perpendicular on both A and V. It has some significance. We'll talk about this thing. So that's why if I write, and that's very important thing, I say that this eta head must be perpendicular on both A and B. It doesn't require that A or B perpendicular. Sometimes it could be, but it is not necessary. But this eta head must be perpendicular on both A and B. Say this is my vector A and this is the vector B. They are oriented in some way. Then eta head must be perpendicular into that two vector. Either it could be that direction or it could be goes to the downward direction. In that case, this eta head is perpendicular on both A and B. That's the direction of vector eta head. It always must be perpendicular on both the vector A and B. It has to be. Eta hat basically giving the direction of that vector, because cross product A cross B actually the vector, right? A B sine theta give you the magnitude, but the eta hat will give you the direction, which direction it will be. That we find out actually using the right hand rule actually, right? Using the right hand rule. I will come to that point. Now fine. So if I write in that way, Ij magnitude into sine theta, what is the angle between the I is that sine 0 degree, right? And the eta hat I do not know, because the sine 0 is really the 0, so that's why it will give me the 0. So that's mean I cross I can write similarly the j cross j, and also that k cross k is becomes 0, because angle is 0 degree between these two vector. What about say that if I write that I cross z? So same way you can write, so I hat magnitude of j hat. Now what is the angle? I and j?
It's a 90 degree.
90 degree. Sine 90 is basically the 1, right? Now what would be that eta hat over here? Look at this. So this is say your x-axis, this is say your y-axis, and say this is actually your z-axis. And this is will be my I hat, this is will be my j hat, and this will be my k hat, right? So I'm taking I and j vector. I say that eta hat must be perpendicular on both vector A and B. So only that k hat is the perpendicular on both I and j. Either it could be the plus k or it could be that minus k. This would be the basically that minus k hat, right? So there is a condition over here actually. This rule actually, if you move, this is a shortcut process actually. Remember, I use it in that way. So if you write down I, j, and k in that way, if you move to the counterclockwise direction, that would be positive. But if you move to the clockwise direction, that would be negative. It's a convention they follow. We will follow that one. Otherwise, it will be make you a confusion to find out the exact direction. So that's why we will follow that convention also. If we move, I'll write it in that way. I, j, k. If I move from I to j, if I write down I cross j, so that's mean I'm moving I to j. Then the third one actually that would be the k hat. It's a positive k hat. So that's why it will give me I cross j will give me plus k. What if I write say j cross I? J cross I means now this time I am moving to the clockwise direction. J cross I, right? In that case, it will give me basically that minus k. So that's how actually we can find out the cross product of these two vectors. So if I write say that I cross j, it will be that k. If you write say that j cross k, it will give you the plus sign, because j cross k actually from I'm moving to the counterclockwise direction. J cross k, I'll find out the I hat. If I write that k cross I, that will give me plus j, because I'm moving to the counterclockwise direction. Remember this thing, counterclockwise will consider the positive, clockwise will be that negative. And vice versa, if you move to the opposite direction, clockwise direction, j cross I will give you the minus k, and k cross j will give you the minus I, and I cross k will give you that minus j. I do not recommend you to memorize this thing. You have to carry this information in that. I carry this information in basically in that way actually. I don't have to memorize. And this procedure actually the same. Whether is a, you can use this idea for different coordinate system also. Whether is a polar coordinate, cylindrical coordinate, and also a spherical coordinate system. You can use that idea. And that way you can also find out that different unit vector in the different coordinate system. Is there any question over here up to this?
No, sir.
All right, let's talk about basically say I'm not going to basically give you the idea of, I'll talk about, say, the polar coordinate system right now. What would be basically that unit vector in the polar coordinate system? Polar coordinate. Should I talk about that, or I should talk about the component, vector component first? It would be easier for you, I think. Otherwise, I'm sorry, I changed my mind. Say I'll talk about that component of a vector. Then I'll move to the polar coordinate. I'll talk about first two-dimensional case. Say I have a vector in the, this is my x-axis and this is my y-axis. Say my vector is A. So and that vector, say that create some angle with this axis. I do not know that one actually. So this remember, vector component is basically that that I say the projection of vector rays towards some direction. It could be arbitrary any direction. Initially, I'm giving you the reference. Then I will use without the reference axis. We can also find out. But this is also a very fundamental thing. So projection means if you put on a light over here, then you will find out the shadow of this vector into that x direction, right? If you draw, so I should use, say, that red color so that you can understand. You will find out some shadow of A towards that direction, right? This is to be basically that projection of vector A along the direction of x. I write this is actually, say, that Ax is a scalar quantity again over here. And if I know this in the x-axis, I have the unit vector in the I hat in the Cartesian coordinate system. Then if I multiply with that I hat, I'll find out this would be my Ax I hat vector. The same way I can find this is would be my Ay Z hat, right? And this is actually your, I shifted from here to here actually, how it's come from. You know that one. If I shifted the Ayj, this will be the new location. Then this is actually head to tail connection. I can write my resultant vector A using the vector triangle law. This is first vector. Head is connected to the tail of the second vector, head to tail connection. So definitely my resultant vector would be that one. So that's why I can write A would be basically Ax I hat plus Ay Z hat, right? That's how actually we can write the vector in the two-dimensional case. You can use that idea also three-dimensional case that I shown you in the previous case. It will be the same for the three-dimensional case. I'll show that one. Don't worry about that when I deal with that three-dimensional case. Axy, Ayj, and Azk. And that's how actually we can express this vector in the three-dimensional case. Now, what is, say, that Ax component of A along to the x direction? How I'm going to find out that one? Say this vector A is create some angle with that x-axis is theta. Now look at this. I'm going to find out that value of Ax and the Ay. So this is actually your vector. It's a right angle triangle. This is actually your angle theta. This is actually the vector magnitude. This is actually that Ax, and this is actually your Ay. I'm going to find out that Ax component. Remember, when you're going to take the component of a vector, always you have to consider the cosine ratio. Never take the sine ratio. Sine ratio will automatically give you if the angle are or the axes are perpendicular to each other, right angle axis. If the axes are not right angle, then if you say that another component, the y component would be sine something, that would be the wrong. That would be the wrong. So that's why always when you take the component of a vector in any coordinate system, I don't care about whether it's a Cartesian, polar, or something like that. So any coordinate system, I will always take the cosine ratio. Sine ratio automatically will give me if the axes are right angle or perpendicular to each other. So that's why I can write, look at this, cos theta by the definition, actually the base, which is ax, divided by hypotenuse is a, right? We can write that ax would be in that case actually that a cosine theta, which is the component of vector a along the direction of axis x. That is actually the ax, this one. Now, what about for y component? If I want to find out the y component, I know this angle is basically 90. This angle, in that case, it would be 90 degree minus theta, because this is actually the theta, right? We know that the total angle of a triangle actually that 180 degree. So 90 plus 9 theta plus 90 degree minus theta, that will give me 180 degree. So that's why this angle is 90 degree minus theta. So if I want to find out that y component, in that case, this will be my base. Again, I will define cos, which is the angle 90 degree minus theta, that will be the base. Base is ay divided at hypotenuse is a. In that case, cos of 90 degree theta is basically, by the trigonometric properties, I'll find out this is will be that sine theta, which would be ay divided by a. That will give me basically ay would be a sine theta. This is actually the component of this vector a along the direction of x-axis and the y-axis. What if, say, the vector is create the angle not in the x-axis, it could be create in any axis, x-axis, y-axis, z-axis. Say, I'm talking about the two-dimensional case first, then it will be easier for you. So this is my vector a, is create an angle the theta over here instead of x-axis. Now what would be that component? Will it be same or it will be different? Now then you can find out the same way the idea I show you over here. So this is your vector a. This angle is 90 degree, right? Now this is actually your theta. This is actually your ax. You can take the projection of that one. This is right. So this is actually your ay. This is actually your ax, right? So this is actually your ay. Now if you define, let's create an angle over here. If I define the cos theta is the base is right now ay divided by a, then I can find out that ay would be basically a cos theta. Look at this. Initially it was ay was actually that a sine theta. Right now ay is a cosine theta. It's changing. It's changing because angle is creating with different axes. But I use that one. I always taking that cosine ratio. The axis is create. Many axes is create, whether it's x, y, or z. I'll show you that one. Don't worry about that. So then this one would be your 90 degree minus theta. In that case, it would be, I'm writing, look at this, cos of 90 degree minus theta would be base. Right now, base is my ax divided by hypotenuse a. It's become actually that ax is become a sine theta, which is different from the previous case. Right? Which is different from the previous case. That's fine. Now come to the say the three-dimensional case. Someone asked me a question regarding that. So I should draw. So this is my x-axis, this is my y-axis, and this is my z-axis, and this is a vector. Vector A is create an angle right now with that z-axis is theta. Now I need to express. I know this vector could be represented in that way. This A would be ax I hat, ay z hat, and azk hat. Am I right? That vector could be represented in that way. Should I show that one? Should I show that one?
No, sir. I guess.
Right, that's good. You can find out. But
Yes.
my intention is I'm going to find out this one. What would be that ax over here? What would be the value of ay, and what would be that az value over here? Right. I have to find out that component of this vector. That's fine. Since it's create a angle with the z-axis, I can say it will create a projection into that z-axis that I can write. Sorry. Removing, replacing from that. So I should remove that part. I can say is create theta angle with the z-axis, then I will say this is length would be basically az, right? Component of vector A along the direction of z-axis or z-axis. Now, what about that ax and the ay? I'm going to take the projection. What I will do, I will sorry. Right. Think about this would be the projection in that x-ray plane, right? I'll find out the projection of that x-ray plane of vector A. Then I'll write this one could be right, say that a xy, the projection of vector A in the x-ray plane. That's why I write in that way. And say this one create angle, not over here. Say it create that over here. Or you can choose that axis, say another angle, say this is actually that phi. Now I'll find out that component is step by step. Look at this. So I can then extend that part. So component idea is over here. This will be that part. Right. This is going to be that part. And this is actually that part, right? And this one is going to be that, should indicate that. Let's say that different color. All right, I used a different color. This length would be in that case ax, and this length would be ay, right? This is the case actually, that component of this vector. All right, az I can find out directly. If you draw that one, you say in that form, right? So this is actually your A, and this is the angle. This is actually that 90 degree, and this is actually that az. So az I could find out directly because cos theta will give me base over hypotenuse. I'll find out az would be a cos theta. I find out that component of vector A along the z direction, right? You create an angle, then it should be a cosine theta. Is that okay? Fine.
Yes, sir.
Now, what could be basically a xy? I know this angle is 90 degree, right? Z axis is perpendicular on both x and y axis. So that means z axis is basically perpendicular on xy plane. So that's why this angle is 90 degree. This angle is theta, then definitely this is going to be the 90 degree minus theta. If this 90 degree minus theta, then I can write a xy is basically a sine theta. Can I write down this one, a xy? That vector, this one would be a sine theta. Can you write this one, or should I show that one?
No, sir.
All right. So I find out that AXY is sine theta. I have to use this one. Why I'm using that? Now look at this. Over here, come over here. This AXY is create some angle. So this one is 90 degree definitely. This is my AXY. This is my AX. Is create an angle the phi over here. My intention is to find out the AX, right? So then I'll again define that cos phi would be base, which is AX divided by hypotenuse is AXY. It means that AX would be AXY cos phi, right? And I know that cos phi value I find out in the previous case actually. So in that case, AX would be AXY is A sin theta. I'll write that one. I will just plug in the value of AXY, A sin theta into cos phi. So this is would be that component of vector A along the direction of X. Now what about the AY? In that case, I can write the AY, which is basically this one. You can say this will be your AY from there also, because I can shift that one from here to here, right? In that case, this angle is basically 90 degree minus that, or you can consider over here is the same. It's not a big deal. You can consider this one would be 90 degree minus phi, whatever you choose, because they are perpendicular. So that's why I can write on directly over here. In that case, I could write a y could be, should I, all right, so let me show that one. So I can write, so cos phi, or it would be cos of 90 degree minus phi would be basically base. Right now base is my AY divided by hypotenuse is AXY. I'm considering this case actually over here, this one, this triangle. This is my hypotenuse, this angle is 90 degree, and this is actually the 90 degree minus phi. So in that case, I'll find out that AY would be a xy cos of 90 degree phi is sine phi. I'll write down that sine phi. Then I can write that AY would be a xy actually I find out, which is a sine theta, and sine phi. That would be the component of that vector in the y direction. Do you understand how you have to deal with that component thing? That's how actually you can find out step by step. And sometimes it could be possible, say instead of that one, say this one create an angle with that x-axis. It could be create some y-axis and the z-axis. Any axis is create the angle. I don't care about that. If I know just this procedure, I can find out the component of that vector in any direction.
So can you kindly show the AXY equal to A sin theta portion again?
Which one? Ax equal to
AXY equal to A sin theta, yes. This one.
Axy.
Yes, sir, this one.
All right. Look at this. Then I have to draw again. So this is my case. This is xy, this, or I cannot draw it that way. This is my vector A, which is create the angle with that axis, right? This is
Yes.
right. This is my z axis. This is my x axis. This is my y axis. What is that? Look at this. If you take the component or the projection, you will find out this is be actually your shadow of A in the xy plane. Can you understand this thing, or can you visualize this thing? So if you put on a light onto that, think about this is a stick. That vector A is a stick. If you put on a light onto that stick, you will find out a shadow into your floor, right? If you make a stick in that way, somehow you make an incline with that. Now, if you put on some light onto that stick, you will find out some shadow of that stick into that floor. That is actually AXY over here. Now, I said
Yes,
that
sir, I got it.
I say that this is actually the 90 degree. This angle is theta. Then this angle is going to be basically 90 degree minus theta, right?
Yes, sir.
All right, now look at this. I'm drawing you for in separate way actually, so that you can understand. This is your AXY. So this is, although my drawing is not exact, look at this. This angle is 90 degree over here. This angle is 90 degree minus theta, right? This is actually that AXY, and this is actually that your A. This is actually my A, and this is a that one, which is perpendicular to that one. Now, this is a different perspective actually. If you think in that way,
Yes, sir.
say if I rotate that one some angle, I hope you can understand that it will be there for you. This angle is 90. This is actually your AXY. This angle is 90 degree minus theta, and this is actually that A. Now I'm going to find out. I'm going to find out the AXY. I'll define the cos of 90 degree minus theta would be base. Base is actually that AXY divided by hypotenuse. Hypotenuse actually that A for this triangle. This is A. Then it's become AXY because cos of 90 degree theta is basically that sine theta, right?
Yes.
It's become A sine theta.
Okay, sir.
That's
Thank
how
you.
actually we can find out. All right. Today I'm not going to start any new topics. Your time is up. Actually, I'll talk about the coordinate system, a different coordinate system in the next day. Actually, the next week, basically, which is going to be. So, do you have any more question after this, or whatever I said? Remember, initially I'm going to slowly. Actually, I'm starting. I'm not accelerating. I'll accelerate a little bit more after 1 or 2 weeks. Definitely I have to. I don't know whether you are coming to, because in my experience is say that after 2 or 3 weeks, step by step, the student number is going to be the de-accelerated present in that live session. It's going to be decreasing. They start, but their acceleration is not very high to reach into that in the timeline into that live session. I hope they start. They start from their. They're thinking in their mind, I will join. But they're thinking, they're trying to join, but they do not join in my live session.
Sir, I think it is because of it's not mandatory. Like,
Yeah. So that's why I'm saying that. That's why I'm
Yes.
saying that.
so if
I
it
don't
was
have any
mandatory, we
problem.
ought to.
If you come, I'll discuss. If you not come, I'll be also available in my this counseling time. But remember, it could be changed actually. I don't know whether some other course actually. I know that, but one of my student saying me in the last day actually that his English course actually taking their attendance in that live session. So that's when they are
Yes.
considering
Yes,
this.
sir. Yes, sir.
Yeah,
Sir, when our first assignment published, sir?
probably in the next week. After the next week.
Sir, and I
Sir,
had a question about the lab classes. When it will
Sure.
start?
Sure. Go ahead.
Sir, I mean, a lab. We will have different faculties for lab classes.
No. There will be no live session for your lab.
Okay.
So what they will do is basically they will give you some instruction about the lab assignment into in the box. Did you find out that lab tab into your box or space?
Not yet, sir. I guess.
It's still probably they are not published. They didn't
Yeah.
publish yet, so they will
Yes.
publish probably in the next week.
Okay.
Then there will be some instruction into that lab tab, so you have to perform that lab following that instruction.
So there will be no live session.
There will be no live session for the
Okay,
lab.
sir. Okay, sir. Thank you.
But remember, if you face any difficulties for the lab, you can post into that. There is a lab Slack channel.
Lab section, yes, sir. Yes.
Yeah, you can post over there if you have any issue regarding the lab, whether you are not understanding, whether you need some help. You can post over there. They will reply you through that. But they are not taking any live session for the lab.
Okay, sir.
All right. If you don't have any question, guys, you can leave. Stay safe. See you in the next
sir,
week.
can you tell me, sir, sir, what is the syllabus of assignment 1?
Still, we didn't decide.
Oh, yes, sir. No problem, sir.
Still, do whatever you are doing. What you have to do right now. Learn the vector first properly.
Yes, sir.
Yeah, then you can. Yeah, it would be definitely the vector, and I don't know whether they will include your motion in the 1D and the 2D. Probably not. They will give you assignment on the basis of vector. There are a lot of things in the vector. All right, Junaid.
Sir, I have a question from a lecture video.
Yeah, sure.
Sir, what does vector displacement mean? I mean, finding the components of that vector.
Vector displacement.
Yes, sir. There's a problem solving you did in maybe SP2 box.
Let me take the which one I said. Is that my?
No, sir. Yeah, that was yours.
How do you know that was in my? So I'm asking you. I don't know.
Oh no,
It-
maybe.
Probably. I'm not sure. Probably I could. Probably because probably I give that for sample problem in the vector.
Yeah, I mean, what does vector displacement mean?
Vector displacement is actually changing its position probably. I forget about
Yes,
it.
sir. In Bangla, it's called Sharon. That's sir.
Yeah, displacement is the that's called in the short.
Yes,
Yes,
yes.
sir. Sir.
In which problem solving video, Junaid?
SP3.
SP3.
Class 1.
Resultant displacement.
No.
Probably it could be. I forget about this thing. I created. I'm sorry.
Maybe, sir. It's
My God, I created that one is 1 year ago. That was 26th August 2020. I forget about totally that one.
so. Can I share my screen?
Definitely. Yeah, I got that one, but we probably is displacement. It's talking about the displacement. Vector
Sir,
displacement.
see question number A. Determine the hiker's displacement for each J. I mean, for each vector.
No. Each day means does the hiker move in one direction in every day?
Yeah. Each
The
day.
hiker began a trip fast, walking 25 kilometers southeast from her car. He stopped and stepped off her tent and for the night. On the second day, he was 40. All right. Yeah. Which point discovered the first discovered? Determine the hiker displacement for each day. Yeah. So each day means you have to find out each vector definitely.
Vector, I mean displacement, here they solved it. I mean they find out the dimensions, actually, the x and y.
So that's when you have to find out that if you say that each day displacement means the you have to basically 25 is travel the 25 kilometer in the first day, right?
Yeah, they just,
You have to express this. Listen to me, Junaid.
yes.
Probably they did actually in the 20 first day it moves 25 kilometer, right?
Yes.
That's a scalar quantity. That's not a vector. Am I right?
Yes, that's a scalar, but they found it at the dimension. I mean, these two dimensions, I and j.
No. Yeah, I'm coming to. I know you are searching that result actually. So that's mean in the listen to me carefully. It's very in the first day it moves 25 kilometer. That's a scalar. So that means it's in the first day its displacement would be 25 kilometer southeast from his car. So that means I have to express that 25 kilometer in term of x and y axis in term of vector actually. That's why it's called that displacement.
Yeah, I mean that. I mean, finding the dimensions of this distance.
Yeah, this one.
Vector. I mean, this is not a scalar. I mean, there is a 25 kilometer and southeast. I mean, it doesn't need a vector.
Yeah, that's vector, but you have to express. If I say 25 kilometers south is definitely it's a vector, but you have we express in term of I and j actually. We are expressing mathematically right now. That one actually the graphical. If you say 25 kilometers southeast, that is the vector, but it's graphical representation. But over here
Yes.
we are doing it mathematically.
Okay, I mean, in a word, finding displacement is finding the dimensions of that vector. I mean, in a word.
Not dimension. Dimension, if you say it will be critically
I mean,
technically wrong. You can say we will express that in terms of basically a unit vector.
Unit vector. Yes, I mean I and j.
Or, yeah. Or you can say the component of that displacement in the x and y axis.
Yeah, I
right?
meant that. Yeah, component. Yes.
Not the dimension.
Yes, sir, thank you.
Yeah, thank you, Junaid. All right, is there any more question? Someone asked me actually regarding one problem. Which one? At the beginning, actually.
So that was me. So
Yeah.
tutorial number 4.
Yeah. So now, can you solve this one?
So I think I can
Yeah.
after the last problem you solved.
Yeah,
So I will
definitely.
try again.
Yeah, try by yourself. Now you
Yes.
can understand. I can say that.
Thank you, sir.
I hope you can solve this problem.
So can
All
we
right,
leave?
guys. Any question? Any more question?
No, sir.
No, sir.
Then fine, you can leave.
Thank you, sir. Assalamu alaikum.
Thank you, sir. Assalamu alaikum, sir.
See you in the next week.
Assalamu alaikum, sir.